Exponential and logarithmic functions, lesson 1, a review. So this goes back to the concepts that we looked at in grade 10. So we will go through this quickly because it should be a review. We're going to use exponential functions. So we're going to explore an exponential function and then use that to learn about logarithmic functions. Okay? So, exponent laws. The whole thing is called a power. Base, exponent. Fairly straightforward. We go through our power laws from grade 10. Product law. If the base is the same and I'm multiplying the two powers, what do I do to the exponents? Add them. If I'm dividing, what do I do to the exponents? Subtract them. Power of a power. So if I have x to the power of m that I raise to the power of n, what would I do to the exponents? Multiply them. Power of a product means that this exponent carries through to both bases. So I have x to the power of m and y to the power of m. So what would happen in the power of a quotient? What would happen to this exponent?
It would go to both bases.
It goes to both bases again. X to the power of m over y to the power of m. With the condition that y cannot be equal to 0 because I can't divide by 0. If I have a negative exponent, how do I make it positive?
Go 1 over the...
So I get 1 over x to the power of m. If I had 1 over x to the power of negative m, how would I make that a positive?
I'll bring it to the top.
Bring it to the top. And if I had something like this, a over b to the negative m, how would I make that negative a positive? B over a to the power of m. Good. And then I would do the power of a quotient, b to the power of m, a to the power of m. Okay? And rational exponents. If I have x to the power of m over n, and I want to write it as a radical. So if I want to use the radical symbol, x is my radicand. Where do the m and the n go? M is inside. And when you say n is outside, do you mean it's here? It's the index. Or I could write it as the nth root of x, then raised to the power of m. So it could make either form. And the reason for that is if I had something like 64 to the power of 4/3, which becomes the cubed root of 64 to the power of 4. Because I can do this calculation myself. The cubed root of 64 is 4, and then I can raise it to the power of 4, which is easier than taking 64 and raising it to the power of 4 and then trying to take its cubed root. But either way, they're still correct. So if we look at class example number 1, we want to write each expression without using brackets and making sure that all of our exponents are positive. So if I have 1/2 times y to the power of -6, how would I write that with a positive exponent?
1 over 2y to the power of 6.
Right. So the -6 with the y brings it down to the bottom. The 2 or the 1/2 stays as it is because it is not impacted by that negative exponent. Okay, what about b?
Is it y squared over 5x to the power 3? Just switch them.
Okay, so y squared x to the power of 3. Does the 5 have a negative exponent?
No.
So it stays where it was. Okay? It's the biggest, most common mistake that is made when we've got a question like that. We see the negative exponent and we want to move everything down. The only thing that moves down is what is tied to the negative exponent. The 5 is not tied to it. Okay? How would I do C?
Put the x to the power 4 on the bottom. Like divide the whole thing by x to the
I could do that. Think of your exponent rules. Bases are the same. What do I do to exponents? I add the exponents, right? When I'm multiplying, I add the exponents. So 3 plus negative 4, negative 1. Y and y squared would give me y to the power of 3. And 4 times 2?
8.
And then if I wanted to make this negative 1 a positive exponent, then I would move it down. So the h and the y cubed would stay on the top. The x would move down. I could do it the way that you were saying, Rachel. And I could put that 4x cubed times y and 2y squared over x cubed. Or sorry, x to the power of 4. It would just take an extra step. Okay, so if I look at D, we use the exponent rules. 24 divided by negative 4. Negative 6. And then M5 divided by M4. M. P to the negative 3 divided by P squared. P to the negative 5. And Q4 divided by Q to the negative 2. And then my final step would be to move the P down. The 6 stays where it is. It's a negative 6. It's not 6 to the negative power. Okay, what about E?
Multiply each exponent inside by the 3 outside.
Okay, so what would I get when I do that?
3x to the power of 6.
Y to the power of
9.
9. Okay, and what about this 3? Does it get a power as well? Yes, so this would be 3 cubed. Can I calculate 3 cubed? 27. By 27, x to the power of 6, y to the power of 9. Okay, and the last one. 12 divided by 3. 4. And then b to the negative 2 divided by b. So if I subtract the exponents, negative 1 minus 1.
Negative 2.
Oh, sorry, not negative 1 minus 1. Negative 1 half. Minus 1.
Negative 3 halves?
Negative 3 halves. So then I'd have 4b to the power of negative 3 halves. To make it a positive 3 halves, move it to the bottom. Where does the 4 go? Stays on the top because it's not tied to the negative exponent. Simplify the following, write the answers with positive exponents. So I'm going to give you a couple minutes. I want you to try to do A and B, and then we'll look at them together. Okay, so how did you do A?
Got 4 to the power of -3, and then x to the power of -3, and y to the power of 6.
Okay.
So then you have to move the 4 and x to the power of -3 to the bottom.
Okay. And when I move the 4 to the
And
power,
you can, then it becomes 64x cubed.
64x cubed on the bottom and y to the power of 6 is on the top. Okay, so how do I do B?
So go 3 to the power of -2, which is 1/9. And then it'd be x to the power of -6 on top.
Okay.
And on the bottom you have 4 to the power of -2 and y to the power of 4.
Okay.
Well, the way I did it, I had like 1/9 on the top and 1/16 on the bottom, and like I just divided them and ended up with 16/9.
Sorry. So then it would be the same as bringing the 4 to the top
Yeah.
and the 3 to the bottom. X goes to the bottom, y goes to the bottom. So then I have 16/9 x 6 y 4. The other way that you could have done it is with this step right here, we could have reversed the whole thing. And then made that a +2. And then it would have been 4 squared, which would have been my 16. Y to the -4, which then would have moved to the bottom. 3 squared, which is 9. And then x cubed, which would have given me x to the power of 6. So you could have looked at it in a couple of different ways. Okay, so class example number 3. Without using a calculator, determine the exact value of the following. So 2 to the power of -3. How do I make it a +3?
So 1 over 2 to the power of -3.
And what is 2 to the power of 3?
8.
So this becomes 1/8. Okay? With 81 to the power of 3/4, this 4 is an index. So it becomes the 4th root of 81 cubed. So the 4th root means I want to think of a number that when I multiply it by itself 4 times, I'm going to get 81. 3. So start off with 2, or actually when you look at 81, the number that should come to mind is 3, because it's a multiple. 3, 9, 27, 81. So this now becomes 3 to the power of 3, which is 27. 25 to the power of 0 is 1. If it was -25 to the power of 0, it would still be 1, provided that the negative was inside brackets. So if it was written this way, it would be equal to 1. If it was written this way, it would be a -1, because I would do this first, and then it would be like looking at this and seeing it as -1 times 25 to the power of 0. 16 to the power of -1/2. 1 over the square root of 16. Because the index would be 2, which means I don't have to write it in there. And what's the square root of 16? 4. Okay. I want to do, I want you to do these 5 questions. Question number 1, A, C, and E. And question number 2, B, and C. But I'm only going to give you maybe about 5 minutes. Okay, changing base. If I wanted to write 9 to the power of 2x, and instead of writing the 9 as a 3, 3 to the power of what equals 9? 2. So I rewrite 9 as 3 squared to the power of 2x. Put that together, and what do I get?
3 to the power of 4x.
3 to the power of 4x. So if I want to take 125 and write it as a power of 5, 5 to the power of what equals 125?
3.
5 to the power of 3. And then it's to the power of 2 minus x. So when I multiply the exponents, what do I get?
Six minus 3x.
Yes. Okay, so now I have 18 times 16 to the power of x, and I want to write everything as a base of 2. So 2 to the power of what equals 8?
3.
3. And 2 to the power of what equals 16?
4.
So again, 2 to the power of 4 to the power of x. So I'm just going to write it as 4x. If the bases are the same, what can I do to the exponents? Add them. So this becomes 2 to the power of 3 plus 4x. Okay, so if I look at D, 512 to a base of 2. 2 to the power of what?
9.
9. So I'm going to write this as 1 over 2 to the power of 9 to the power of 3x, which equals 1 over 2 to the power of what?
27x.
Okay. Is this actually a base of 2? No, this is a base of 1/2. So I want to write it as 2 to the power of something. So what do I do to bring it up?
Negative 27.
Negative 27x. Good. And then the last one, 16 over 81 to the power of x plus 5, and I want to use the base of 2/3. So 2 to the power of what equals 16? Pardon?
2 to the power of 4.
2 to the power of 4. And is 3 to the power of 4 equal to 81?
Yes.
So this becomes 2/3 to the power of 4 to the power of x plus 5. So then this would become 2/3 to the power of what?
4x plus 20.
4x plus 20. Okay? So now what I would like you to practice with is question number 4, A, C, and E, and 5B. And again, I'll give you about 5 or 6 minutes. So we're going to look at solving equations with a rational exponent. The volume of a beach ball is 50,963 cubic centimeters. Determine the radius of the beach ball to the nearest tenth of a centimeter, given that the volume of the sphere is 4/3 pi r cubed. So if it says Sarah and Lee are solving the problem and the first 4 steps are identical to each other. They substitute in the volume of the sphere, multiply by 3, and then divide by 4 pi. So I'm left with 3 times 50,965 over 4 pi. So Sarah completes the solution by taking the cubed root of each side. So if she takes the cubed root of r cubed, I get r. And then it's the cubed root of 5 times 50,965 divided by 4 pi. So when we go to put this into the calculator, we have to watch our order of operations. So you might find it easier to actually do the calculation underneath the radicals separately. So bracket 3 times 50,965 divided by bracket 4 pi. And then I end up with this answer, 12,166 decimal. So then if I take the square root of that answer, so I hit my square root button, and then if I go second and the negative button, it takes the answer.
Should be cubed root though.
Yes, it should be. So cubed root I get through math. And that's selection number 4, and then yes, answer. Enter, and I get 22.9, which means I'd round this to 23. Okay? If I don't put that 4 pi in brackets, it's going to end up doing something wrong. So I need this to be separated from the above calculation. Lee completes the same question, but instead of taking the cubed root, he raises each side to a specific power. So what power would I have to use on r cubed to get it to r? In other words, what number that when I multiply it by 3, I get 1? 1/3. So then I've got the same calculation that Sarah made, only I raise this to the power of 1/3. So there's my entry, my 12,166, and I can raise that to the power of 1/3, 1 divided by 3. If yours doesn't put it in the exponent spot, then you'd have to go bracket. So if yours had the ANS, and when you press the power button you get the little arrow or the little hat, then it would be 1 divided by 3. I still get the same answer. The purpose in doing this is just to show you that you don't always have to go to the radical. Because taking the nth root, so taking the 5th root of something, it's a lot more work because I have to press the 5 first, then I have to go to the math, I have to check number 5 so that I can make that the index, and then I put my number in. Whereas instead, what I could do is I could take my number and raise it to the power of 1/5. And I'm not having to second function anything. And I still get the same answer as I would if I took the 5th root. So this still equals 23.0. So now if we look at class example number 5, if I have x to the power of -4/3, how do I go from the -4/3 to the power of 1?
Negative times by -3/4.
Times by -3/4. So I'm going to take 81 and raise it to the power of -3/4. So then this becomes 1 over 81 to the positive 3/4. Which becomes 1 over the 4th root of 81 cubed. So what's the 4th root of 81?
3.
3. And what's 3 cubed?
27.
27. Okay, so now if I look at B, I have 3x minus 5. I have an entire expression raised to the power of 3/2 equals 27. How could I change this, or what could I do to this to make this a power of 1? So what could I multiply by 3/2 to get to 1?
2/3.
2/3. So if I raise this side, So on the left-hand side, the 2/3 will cancel out the 3/2, and I'll be left with 3x minus 5. And then 27 to the power of 2/3 is the cubed root of 27, which is what? First of all, a step back, 3. So the cubed root of 27 is 3, and then when I square 3, I get 9. So I get 3x minus 5 equals 9. How do I solve for x? Add 5 to both sides, which gives me 14, and then do what? Divide by 3, and I get that x equals 14/3. So I'm going to add questions 6, B, and C, and then 7, 8, 9.
I didn't see 8 on there.